Hey, hello, and welcome in this video. This is the first video of this channel. This actually comes from a challenge that I have taken for the next year, 2026, to be consistent on making videos. So, with that, I have decided to start teaching in YouTube, and this is going to be my first video. So, let me give you overall perspective on this project that I have taken, and what is the expectation that I have from the audience, and what the expectation that the audience might have from me. So I have decided to start with this playlist covering the core computer science subjects. Now, there are many ways you can define the core computer science subjects, but the one that is universally followed, not universally but globally followed, in various universities across the world, about teaching the absolute basics of computer science. And these subjects are especially, the first is digital electronics, or sometimes called digital logic design or digital design, mainly referred to as DLD. The other is operating system. So if digital electronics is the cellular structure of a computer, then operating system would be the operational principle, the way all our systems run. So between these two, here comes anatomy, and what goes inside it or between them is computer architecture and organization. So this tells us how various systems in the computer are developed, like processor, like memories, like input output system, like storage, all those. Then the issue is these devices, they speak binary. Sometimes they speak different type of binaries. So we need some sort of interface between these hardwares and the human who is using it. So that layer of interfacing is operating system. With these three subjects, we mainly covered the hardware side of the story. Then the software side starts, and the absolute basic of those would be programming in C. Why C? Why not Python? Why not any other modern languages? Because through C, you can actually explain a lot of things that are discussed in computer architecture and operating system. Problem is, in high level programming language like Python, all these nitty gritties are sort of embedded inside the language. So when you say, I want to create a list in Python, behind the scene, it creates something called a linked list or a dynamic array structure. And how exactly these structures work is the code that never gets revealed to you. So to understand how exactly these computer architecture, organization, operating system, all these concepts that are discussed in those subjects are actually work in action, you need to do it by yourself. And the first way of doing this is getting a skill of writing a code through a programming language, which is C. Once you understand that, then we will learn using the same language C how we can give more complex instructions. And those instructions would be first be written in terms of algorithms, and will then be applied on certain structures called data structures. So you can think of data structures and algorithm, or DSA, is the way that you can encode your logic into a programming language like C and give that program to a computer with a given architectures and operating system, and that will do its job to create signals that will run through these digital systems to make your computation possible. So it's a very important subject, DSA, and we will I'll also create a playlist on this, one of the most important subject in computer science, in case if you're not staying in a development job. Right. Um, the next is, after we study DSA and programming language in C, we may ask ourselves where all this comes from, where this how this programming language actually work, right? So all these questions would come from a mathematical model that we need to understand, and this is called automata theory, sometimes called theory of computation or TOC. This subject tells us the fundamental mathematical model from which this subject computer science comes from, and all these programming languages, how they work, where they come from. So some of the questions that you might not get answered trivially will get that essence through this subject, which is automata theory or theory of computation. This is pretty much the other side of the story, and this is pretty much the software side of the story. So if this being the hardware part of computer science, this is the software part of computer science. And then the final bit is to study a couple of additional content, for example, some specific systems that we need to understand. One is called database management system, or DBMS, and the other is computer networks. Okay, so networking, database management system, these two are two other systems that you need to learn, and these are more of into the system side. So DBMS is a very large scale computer system, so it actually runs on top of hardwares and it manages storage, and there are multiple softwares, and how softwares are built you have understood. Network is because it's nevertheless to understand any modern computing system are network based, so they communicate with other computer systems. So these communication is possible through certain rules and regulations that are standardized, and this is the logic and design and theory of computer networks. The other subjects which are important in this case is software engineering. This is the interfacing of these core computer science subjects. So I said 10 core subjects, so 8 of them are the core of the nucleus of the cell, are these 8 subjects: the hardware side, software side, and the system side. Now, software engineering will say, what about the money side? So, just like machines are manufactured and following mechanical engineering principles, similarly, softwares are also manufactured through software engineering principles, and those principles tells you how to develop a software. Writing a program is a very mere a fraction of the truth, so you have to kind of accumulate all the programs into a systematic form to give rise of a software system, and production of such system requires certain regulations, and that is what software engineering all about. It talks about where the inception starts, how softwares are built, what are the phases of building software, what are different ways you can build softwares. All this management side story is something which is software engineering. So till now, this is a science. Till now, it's a science. You mainly see a lot of equations, formulae, and stuff. From software engineering, your thing will be different. You will see more into processes, more into pipelines. The last but not the least, the most important subject, which is number 10, called discrete mathematics. In some cases, discrete mathematics is studied as a first subject, but I prefer to actually cover this topic, discrete mathematics, at the very end, because once you understand the first 9 topics, you will get a superpower. The superpower is you will get adequate amount of examples to relate things which can be expressed in abstraction through mathematical languages. So once you get enough of experience, then when I say, all right, here we want to start understanding the generating function of a Fibonacci series, Now you have already have one-to-one experience with Fibonacci series when you wrote some programs of simulating that in C, or you analyze the complexity of that series in your DSA or data structures algorithm sessions. So now mathematically what they actually mean would be more meaningful here. Discrete math is not an essential computer science subject if you are very much into development and programming. A lot of people without even a degree in computer science, any formal education, can go and make big in the tech. The reason we need discrete math, if for example you prefer to get into the area of research and development, so in that case you have to go and solve problems at the core of certain computing systems, which for example, I want to add a new feature in Python language itself. So that sort of a change is done at the very core of Python. It's not writing a code in Python. So discrete math helps you to do those kind of work. So if you're in research, then you have to mathematically model things, and for that modeling certain language is used, and this language is not the natural language you speak. This is a language of mathematics, and the branch of mathematics which involves the symbolism required to understand computer science theoretically is discrete math. A glimpse of discrete math you will obviously get while studying automata theory. So automata theory will give you some sense of mathematical modeling, but it's totality of modeling actually be realized in discrete math. So that's it. These are 10 topics that I have sort of sorted out to make this course. So these two highlighted are more mathematically heavy. If I kind of put um, the other subjects, so electronics and DLD, these are a bit mathematically heavy subjects, so I also put it here. um, Database management, only very few maths will be involved, so I'm gonna just put in a different color. So let's say um, DBMS, networking, and operating system and architecture. These are more system specific topic. Okay, if you understand how things are, like Lego boxes are connected, it's that. I would also group DSA and programming a different skill. So if you choose DSA as one of your favorite subject, then you need to also be good in programming. So these two go hand in hand. Programming and DSA go hand in hand. System topics, for example, DBMS, networks, operating system, architecture, they go hand in hand. Um, Automata theory, discrete mathematics, a bit of DLD, they go in one group. And you can also think of the software engineering, we are completely different breed. It encompasses a bit of system engineering flavor, a very tiny amount of management and mathematics, but a lot of common senses. This huge amount of requirement of common senses make this subject so interesting. So I hope this has been informative for you. I'm looking forward to see your feedback. I normally prefer to do this kind of teaching, like a live, barely interrupted, and completely a notebook driven teaching. So if you like this type of teaching, do let me know. I'd be highly obliged to reply you back and implement changes that you may recommend, and I can constructively add in my videos. So with that being said, thank you very much being the viewer of my first video, and I hope I'm gonna make the following videos very soon, and we'll be in touch. With that, Satoshi Ghosh signing off. Thank you.